this whole tilt thing here that I've been doing this past year, I got the idea from Bilu. I'm not kidding.
Are we gonna keep on dividing? Are we gonna keep on fighting? Are we gonna keep on dividing? Well, are we gonna keep on fighting? Are we gonna keep on dividing? Are we gonna keep on fighting? Are we gonna keep on dividing? Well,
sound level.
Right, you see the water level? See this?
I see it, yeah.
Right, there's another one over here on the other side. Over here. See that?
Uh-huh. Yeah.
And this is a tube.
Uh-huh.
So it's just one end to the other end. Tube, the water equalises across the two. And then you're right. Hydrostatics, as Cleary says. So how long do you reckon this tube could be? Because I mean, this is a tool for establishing a horizontal plane of reference. This one will be level with this one all the time. Mm-hmm. It'll equalise out. How long do you think that tube could get?
As in the maximum length. I would have no idea.
About 100 metres.
All right.
Yeah. What about a mile?
I don't know. I haven't seen one that's a mile long.
Do you reckon you can imagine one though? Could you? You can imagine.
Yeah, I guess.
You can imagine a tube over a mile, filled with water, and being able to place each end at a position where the water isn't pissing out.
Mm-hmm.
So that would be, you call that level.
Yeah.
Yeah. Now I'd say that's horizontal. Would you say that would be horizontal?
Yeah, it would seem to me like that.
Okay.
Be careful of me.
Yeah, Manizzle. How's it going?
Not too bad, not too bad. How about yourselves?
Fine, thank you.
Oh, good.
Nice.
Where are you from, Drizzle?
Guessing by you guys' accent, I'm from across the pond, as in the channel.
No.
Or maybe not you, Primate. Well, I think Bev, you're from the UK, right?
Aye.
Aye. Yeah, I'm from the beautiful country of the Netherlands, so close to yours.
I did mean, actually, which server have you come from?
He's just walking past like Rumpus.
Yeah, was you just dropping by?
No, I heard some talk in Gem's server about Emma's Discord.
Ooh.
So I was wondering what that was all about.
Right, I bet it was really good. I bet they were dead complimentary over there, weren't they?
No, it wasn't even in the sense of that. They said, well, the text message they were talking about said something like, I know Guy X from Emma's Discord. So I was like, what's Emma's Discord? Hence this.
Yeah. Well, welcome.
Thank you.
Are you a Glover?
Yes, I am.
Ooh.
Ooh, excitement.
Which
Excitement.
Which Glober model do you go with?
I don't know. What can I choose from?
Well, there's the drop or the hump. Both
Drop
of
or
them
the
are
hump?
Kozlowski models, yeah. But the Kozlowski nutsack drop or the Kozlowski Bislin hump.
Mm-hmm.
It's
I'm going for the sandwich model.
tricky one. Yeah. Most people like to say they're both the same, but
they're not.
no, they're not. You can't have a drop being a raise, can you? They're not the same at all.
Would not seem so.
Are you like you live in Holland, right? It's
Yes, I do.
it's pretty. Let's say, like you've got a good canal system, haven't you?
Yes, we do.
So you'd be used to water levels.
Well, I myself don't have a boat. Some of my mates do, but
You don't need a boat to
Yeah, you don't
know
need to,
about water
to understand the
levels.
level.
yeah, we're talking about the canals.
Yeah.
But you don't need a boat, do you?
I need a boat to sail the canals.
You don't
But-
have to sail the canals. To know the level. I mean, like, what do you have? You have a different, like, you don't have sea level, do you? You have
I
a
have lake level.
standard level or something like that, is it?
I do not know what I have.
Amsterdam. You not have like a, like how you work elevation and all of that.
That's usually done with well, elevation of construction works is usually ground level
Yeah, that
because
would
parts
be.
of the Netherlands are under sea level.
Yeah, that's what I mean. Like you have a standard, don't you?
Yeah.
You have it's called Amsterdam standard level or something like that, I think. But it's
possibly be
it's a
true.
straight line, right?
hmm
Yeah. Are you practical or scientific or computery? What'd you go with?
Well, I used to be a computer nerd, not anymore. So I guess somewhat in between, practical and sciencey.
So you've done some practical work, like in construction or anything like that?
Yeah, predominantly helping out my old man.
Yeah.
But
Well, do you imagine level? The what we use, the tool is a level. That's a tool for establishing a horizontal plane of reference, right?
yeah,
So a water level, a tube. I mean, you can imagine a canal from one lock to the next. I bet you've got some of them big ones, haven't you? Some canals that are quite long.
yeah, we do.
So without the lock system, because you need the lock to raise up and down, right? If you don't have a lock in a canal, that surface of the water would be a constant elevation, right? As in, it wouldn't raise up or drop down anywhere. It would all be the same from one end to the other.
Yeah, without interference, the water level is a water level.
Yeah. So that would be physics would say hydrostatics, but that would be one straight line.
Yeah.
That's why they don't really like to come here, because reality bites, and it's not on the model. Have you ever tried to see if you can get that to work
What, those measurements?
on a model? Yeah, horizontal water level.
No, I haven't myself.
I've had it explained to me like putting a clipboard on top of a basketball. That would be like a horizontal plane on top of a spherical object, wouldn't it?
Yeah.
Do you think that's what water does? Well, I mean, I do. That's what water establishes, a horizontal plane.
Yeah, that makes sense.
can you work out how that would happen on a ball?
Now with Earth being a ball, water lies on it level. Level being a tangent to the ball.
Horizontal, yeah. A straight plane. Like a horizontal plane of reference. A plane's a two-dimensional.
Mm-hmm.
Yeah, with no curvature.
Well, I could see how that would work. If the ball's very big, then
Well, we've
large
got.
parts of it would
Have
be
you
level.
heard of the Black Swan?
I've heard of the Black Swan, yeah.
Have you heard of the Black Swan as in the logical argument?
Yes.
Well, I thought,
Modus tollens.
yeah, brilliant. So when QE did that, I thought it was great because I like the logic. I think very logically. But I didn't think QE did it justice, right? Didn't do the logic justice, let's say. Because in order to properly logic something, you've got to break it down to its simplest component. Take it down as though you can't make it any simpler. Rock solid basics.
It's talking about the Socratic method.
No, that's just asking people questions, isn't it?
To get down to the very bottom.
Yeah, no, well, the logic. I mean, the logic is as simple as you can get, right? And basic logic is the easiest way to describe things, so the most people can understand it. I mean, but you have to take logic as what logic is. It's just very simple and very straightforward.
Mm-hmm.
So, do you want to hear my? I call it the Black Swan, but it's like the mother of the Black Swan.
Go ahead.
Okay, right now, if the Earth is a spherical object, P, you go along with that.
Yes.
It's a good antecedent. Then, the surface of liquid water must curve. Consequent, Q. So, would you go along with that the surface of liquid water must curve in order to wrap around a ball?
Mm-hmm.
Yeah, if the Earth is a spherical object. As we go modus tollens now, right? So, as we've just decided and just dealt with that liquid water, the level of liquid water, which would be the surface, is a horizontal plane of reference. So therefore, I would say that negates the consequent Q, and not Q, and if not Q, then therefore not P.
Wait, go ahead. What was the last argument you said after P and Q?
The water
Uh-huh.
level establishes a horizontal plane of reference. Yeah?
Mm-hmm. Yeah.
Well, then that would negate the curvature of the surface of liquid water. Therefore, not Q.
Well, that's like putting a water level on a basketball. That would measure level.
Yeah, it'd still establish a horizontal plane of reference, wouldn't it?
Mm-hmm. But then you would have a level liquid, so to say, on the ball.
Yep.
So this ball can have a level
Yeah,
liquid.
could you do it on the side? Could you put a water level on the side of the ball?
If you roll the ball around, yeah.
So, in order for you to carry on with the ridiculous model, then you're willing to say that everybody's on the top and also all of the water is on a horizontal plane. So are you sort of saying that that circular bit is sort of imagined underneath the horizontal plane?
I'm not saying that it is if the Earth was curved, then level could exist in that fashion.
It wouldn't be a horizontal plane though. It'd have to be curved, wouldn't it? But horizontal isn't curved at all.
It would be locally level.
What?
Because if you take this ball, and now as you said, if I put this water level on a basketball on the top, it will read level. And let's say that this basketball has some kind of attraction to objects, which would be the reason that water or liquids seek level, then it would not matter on what side you would put that water level on. Because
horizontal level, right?
Yeah, then it would always read level.
Yeah, horizontal.
Yeah, on that pit.
Yeah, well, how's that bit? What do you mean?
Well, the tangent would always be horizontal.
Yeah, but how big's that tangent? I mean, you've just turned a horizontal plane into a tangent. How did you do that? You just put a circle underneath it.
Yeah.
I mean, that was nice. I like it. So you've brought a circle along underneath the horizontal plane. Now, how big would you imagine this? Because you admit that it is definitely a horizontal plane of water surface establishes a horizontal plane of reference. Hydrostatics.
Yeah, my glass of water is flat. It's level.
Yeah. Do you know what a water level is? Do you?
Yeah, I use them several times.
Nice. How big? What was sort of what distance?
What the distance or how long my water level is?
Yeah.
About a meter.
You use the water level 1 meter long.
Yeah, it's a 1 meter stick, and then the level part in it is of course smaller.
Yeah, I don't think you know what a water level is, do you? Are you thinking of like a spirit level?
Oh, then I think my language barrier is in the way here.
Yeah. Maybe. I call that one a spirit level, the stick one.
Oh, you mean the flexible one?
Yeah, the one that's just like a tube that you fill with water, and then the water equalizes. Do you want me?
Oh yeah, now I see what you mean. Yeah.
I'll just wipe the board. Right, I'll show you what a water level is here. Let me just switch the camera on. Video, can you see that?
I see it, yeah.
Let me just get it. Right. Oh, you can't really see that, can you? Let me just move it over a bit. Oh. Right. You see the water level? See this?
I see it, yeah.
Right. There's another one over here on the other side. Over here. See that?
Uh-huh. Yeah.
And this is a tube.
Uh-huh.
So it's just one end to the other end. Tube, the water equalizes across the two. And then you're right. Hydrostatics, as Cleary says. So how long do you reckon this tube could be? Because I mean, this is a tool for establishing a horizontal plane of reference. This one will be level with this one all the time. It'll equalise out. How long do you think that tube could get?
As in the maximum length. I would have no idea.
About 100 metres.
All right.
Yeah. What about a mile?
I don't know. I haven't seen one that's a mile long.
Do you reckon you can imagine one though? Could you? You can imagine.
Yeah, I guess.
You can imagine a tube over a mile, filled with water, and being able to place each end at a position where the water isn't pissing out.
Mhm.
So that would be, you call that level.
Yeah.
Yeah. Now I'd say that's horizontal. Would you say that would be horizontal?
Yeah, it would seem to me like that.
Okay. Well, there's not really much use to. I'll show you the test I've got. Right. We've developed this test. And this is come around because I said to someone that the water level, or levels in particular, I said a level doesn't rise or fall because that's horizontal, right? It doesn't do that, and it doesn't do that. It's just horizontal all the way across. And somebody challenged me and said it wasn't. So I found a way of proving it, right? So let's see whether you think this is good. We put one water level that goes all the way across, and we have one in the middle. Right? Now, if we fill this water level up here, then it'll fill up to here because it's level. Right? It's got to have its level. One in the middle, where would you put that?
I would say on the same.
Yeah, same. I would too. Right, now, in order to, some people say that that's not right. They say that this one should be a bit higher, and we say that's a little bit ridiculous, right? Some people say this one should be down here, and then this one also, but I mean, obviously water levels don't work like that either. So what we've done in order to show these other people, right, is we get a water level like that, and then we get another one and put that like that. You see that?
Two small
So we've
ones.
got made small ones, yeah. So if that's the full distance of 1 mile, this would be half mile, right? So what you say is you put that, fill that one up, so it's the same as this one at this end. Then this one here would fill up, and it would show the same as this one, wouldn't it? And then the same, you do the same at the other end with this one, and then it would fill that one up there, right? So that would go to show, if you were a practical person, right, that the only way that all of these could be at the same level, because these ones here, right, are sort of, there's 3 different water levels there, and they're referencing this end and this end and the middle, aren't they, all together? So if all of those 3 are the same level, then it's the same level all the way across, right?
Mm-hmm.
This is in reality. Would you agree?
Yeah, if you would have a mile-long water level, yeah, sure.
So, have you ever heard of a water level a mile long?
No, not in the way you've drawn it.
Would you say that would be a valid test to prove that water level was horizontal?
I think that the problem then would lie if on the ball you would have a universal attraction down.
So that wouldn't be possible, would it?
I think it would, or how you say it, is like water being level, just the general body of water.
Yeah.
It would say bend after an X amount of distance.
Yeah,
And
it should do. It should curve, right? But this shows it's a straight line. No, there's no curvature. Right? And if the water level can't establish a horizontal plane of reference if there's a curve there. That's why we're showing this test. Sort of gives you a proof, doesn't it? I mean, just looking at it like that's a sort of geometric proof. Because you could say that this is a straight line here between this one and this one, and this is a straight line between this one and this one, and this is a straight line between this one and this one, and you can't have two straight lines sharing a common segment. That's a proof within Euclid. So that's sort of a Euclidean geometric proof that it's all a straight line. In practical terms, the true meaning of geometry, actually. Earth measurement. We're using the surface to make a horizontal.
yeah, I think I can see what you're getting at. I
So
think the problem, at least for me imagining this scenario, is a scale problem.
Scale.
Yeah, like how would it look like on
What sort of
the
scale?
globe size?
Yeah, that's what we was trying to get at the beginning. What sort of scale do you think this this tube of water would stop establishing a horizontal plane of reference? What scale?
No, the thing I'm thinking about at the moment is, well, you could say that that line you've drawn, the elevation would be constant, for example.
Yeah, it's a straight line.
If I would hang it at a certain height, yeah, the elevation would be constant.
Yeah.
And on a ball, a constant elevation would also be possible.
But that would be a curve, and that's a straight line.
Yeah, but if you're how do you call it? Say that or determine it is a straight line based on elevation. Say like I start at 5 meters high.
Because of the straight line segments, right? You use geometry to prove things, don't you? I mean, that is where proofs have come from within geometry, and that's definitely all about straight lines and curves and stuff.
Straight lines.
Yeah.
Yeah, I see.
So, I mean, this is our what we call the reality model. Do you want to have a go at the Kozlowski curvature conundrum? And we'll start imagining models.
Oh, well, I've never heard of that Kozlowski.
Have you not? Do you want
word.
to have a go? It's fun. I'm telling you, you'll love it.
Yeah, sure thing. For a little bit, because I've got some
It's quick.
assignments
Won't take long.
in front of me.
Yeah. Right, so we start off, we want a horizontal, because horizontal, it is like the reality measurement thing, isn't it? Now,
Mm-hmm.
so on this, what can you see on the thing? How high can you see up there?
Yeah, I can see it. I can see the line.
Okay, so we have 32 inches, 1 mile. Right? Left to right scale, 32 inches, 1 mile. This scale, vertical scale, 1 to 1. Right? Reality scale on the vertical, and 32 inches to 1 mile on the horizontal scale, right?
Mm-hmm.
So this is a horizontal. Right, this is your horizontal. Now, you're on the model. This is the Kozlowski nutsack drop. So the first one, Kozlowski nutsack drop model. Now, horizontal, you've got the problem is it drops from the horizontal on this model. Any idea how far it drops?
And was it 8 inches per mile squared or something?
Okay, well, so
Drop rate?
over 1 mile, because we've got 32 inches to 1 mile, so 8 inches we've got to drop. Here we go. 8 inches there. So we've got a water level here, and then we've got another water level down here. Right, 8 inches lower. You see that? So that's
yeah,
your.
see the thing. Yeah, I see.
So that's your 8-inch drop. This is down here, 8-inch drop. Right? But this leaves you with a bit of a problem. This is where Rumpus came last night when he. I mean, like, when you did it, you put the other water level over here. Well, Rumpus came and he did this. Which it sounds all well and good because you've got a model and you've got your 8-inch drop, but that's if you're there. Can you imagine being stood here?
Mm-hmm.
Where's that? It's a bit of a problem, isn't it? Because these water levels don't change from depending on where you are at all. The water level stays the same if I'm stood here or if I walk over here. This one doesn't move. But on the model, you've got 8 inches drop. But then if you come over here, what have you got on the model? You've got 8 inches drop again. Haven't you?
Because you've walked another mile then.
Yeah, but you've walked back. You've just walked from 1 mile, dropped down, and then walked back again. Oh, and you've ended up down there. So this bit that was here, of a water level, because you've walked away from it, down here, and then walked back again to over here. It's a bit of a hard one to try and get around that one, isn't it? Like, once you've dropped down 8 inches, and then you've come to this end, that's we can throw this one out, right? Ridiculous. You'd be that one is one of the. I don't know many people that do that. Rumpus ran away whenever he saw that. But here's the other one. This one. Oh. compass is broke. Oh, bloody sound. Right, now this. Have you ever seen that one where that guy, what was he called? Southley or something. He had a
Soundly?
bridge. We've took it back. Dave Rackier's bridge. He's where he was.
I think he just got the. Well, what name did you just say?
Soundly?
Oh, right.
Soundly. Does that sound right, Bev? Soundly.
Southley. Yeah, it sounds something like that, right?
Was
Have you
he
heard
in
of
the hotel?
Have you heard of Jesse Kozlowski?
Jesse Kozlowski. Doesn't ring a bell.
But you've heard of what's his face?
Southley.
Right. Well, you've heard of his? He's took a picture of a bridge, didn't he? What's he called? Southley.
Yeah, I've heard some people, or at least I heard the name Soundly, but I don't know what he does, if he has a YouTube channel or...
Right, well, this is the next model. We have a guy stood here. He's pretty sad. And he's got a water level. Right?
Mm-hmm.
So he's got a water level like this. And like you imagine if you've got a dropper line down there, and that would be perpendicular to that. So this is a level that you have on here. So this one to this one, I mean this one's a little bit more like the one that you originally said, right?
Mm-hmm.
But you've got a hump in the middle, right? So there's a raise up there. Do you know anything about the maths of the model?
Well, depending on which maths are you talking about the size?
You have you have to sort of you have to lose the 8-inch over the full mile, because now you've got these two have to be level. Otherwise the water will piss out, wouldn't it? So you have to have these level, but you know what that means once you put them level, do you know, for the maths? For your model, do you know what that is? If this is 8, full distance,
Mm-hmm.
what would that make this?
If that's an 8-inch drop, then it would be a mile distance.
Yeah, but it's not a drop on this model. This is the, I mean, that Kozlowski nutsack drop was the 8-inch drop.
Mm-hmm.
Right, but it was ridiculous, wasn't it? Because you drop and you're always dropping. Fallacy, right? So you have to lose that model. You can't possibly go for that. So this one here, it's level from there all the way to there. I mean, these two are level. So the water's not pouring out or anything of either end. But because that's level, then it puts this as a sagittary. And the 8-inch is a quadratic equation, isn't it? Because it's 8-inch per mile squared.
Yeah, parabola.
Yeah. So at the half distance, do you know how it works? It's a quarter function, isn't it? Do you want me to give you a hand?
One sec. What was the exact question?
He
What
said,
happens
like,
to...
Yeah. If because this is the Kozlowski-Bislin hump. Because these are level, this has to go up. You have a hump in the middle. Do you know what that number should be? Is the question. It's all right if you don't. I mean, I can tell you.
I'll go ahead.
It's 2 inches, because you have a quadratic equation for 8 inch per mile squared, which puts this at a half distance. But because it's quadratic, you have to quarter it, so it's a quarter function. So 2 inches. So on this model, the Kozlowski-Bislin hump, what you have is a hump in the middle where it goes up at 2 inches at the half distance. So this is why we call it the Kozlowski curvature conundrum, because on one model you have a drop, and then on this model, because I mean, it's because Jesse Kozlowski said the water level drops down from the horizontal plane at a rate of 8 inches times the distance in miles squared. So that was the first one we did. It drops away from the horizontal. But then, when he went to go and see Southley, and he drove a car with a thing on the roof, he some GPS thing or something, he banged it on his roof, and he drove over the bridge there and back, plotted a load of coordinates, a load of points, right? They were about 5.8 meters all the way across the water, right, in a straight line, horizontal. And then he handed all of those coordinates over to Walter Bislin. Have you heard of him?
The guy with the curve calculator?
Yeah, I think he's done that. I think he's done a bit of maths, yeah. He's a model maker. Well, he used all of those coordinates that Jesse Kozlowski gave, and he gave him a model. And the model for that bridge had these 2 points here, level, line. I think he called it a chord. Does that sound right? He has a chord that goes from here to here, and the bit in the middle, like, lifted up. There's a sagitta. So
if the two people were holding a rope.
No, he drove his car over the bridge. Like, he started at one end and went all the way over the lake, right to the other end, plotting coordinates. Then he handed those coordinates over to Walter Bislin, and Walter Bislin made a model, and the model had a big curve in it like this, and then he had a line like this. Wait a minute, I think it was green. So I might see if I've got a green. Yeah, I've got a green. Right, so he has a green line here. Like this. Oop. I hope it's straight. It's not, is it? There you go. Ignore the first one. Right, so that's a right angle. Right, he says then, well, that's a chord, the green one. That's a chord, and he says, so that's from the first level point to the last level point, and then this bit here is where it goes up. I mean, that's on Walter Bislin's model, right? Because, I mean, it does sound a bit ridiculous. It's nearly as ridiculous as the big drop that come down here. This, but I mean, this goes up. Definitely different models, right? One goes down constantly, even on the way back. But this one goes up in the middle. Do you know how big that hump is on when Walter Bislin made that model for Jesse? on Lake
idea.
Pontchartrain. Do you have a
would
guess? It's 23 miles all the way across. So, because that's the weird thing about this particular model, right? No matter how long this chord distance is, these two at either end are always level. And the only thing that changes is this gets higher. The water actually gets higher in the middle. So if this is 23 metres like Walter Bislin made for Jesse Kozlowski, what do you reckon? How high do you reckon that bit would be in the middle would be?
I don't know, like 200 inches.
Ooh, 28.5 metres. Goes up in the middle over that bridge. Have you seen it?
No, I haven't.
The bridge that Southley did a picture of. Dave Rakier for life. He's took loads more pictures than Southley of it, and they're all there's not much curvature in them, so it seems like Southley made a like, he took a picture and there was a bit of curve in it, probably refraction or something, and I think Mick West said something about it being perspective compression magnifies a slight curve, but there would have been a bit of refraction in it somehow because it's a really shallow lake, plenty of air and water and refraction, so there would definitely have been some refraction, and the technique he uses magnifies that. So, but anyway, Walter Bislin made this model that had a 28 metre hump in the middle. So if you imagine, like, I know you went with the normal model where water was level and horizontal, but if you were to have one of, if you were to think you lived on a model rather than reality, but which one of these two do you reckon you would choose?
I would go for this one. You point that out.
Yeah, I think most people do. Eventually, so like initially they think they go for the drop one because that's what the model dictates, isn't it? Depends how you're approached with it first, isn't it? I would say.
Yeah, and if you view it as a starting point and you go into a certain direction, then you would follow the line of the circle.
Yeah, but this water level thing really messes you up, doesn't it? Because it's got two ends. It's not just at one place. It's like each far end.
I think then the disagreement, so to say, would be that either level is always perfectly horizontal,
Yep,
or on a big ball with a downward attraction, level would be perpendicular to a plumb line, or then, for example, equal elevation.
Yeah, perpendicular is two straight lines, though, right?
Mm-hmm.
So you can't have perpendicular to a curve, because a curve isn't a straight line, is it?
Yeah, but if you compare it to the elevations,
No, it's
because
perpendicular.
that is usually the.
Yeah.
For example, if
one's
I
horizontal and the vertical, right? Perpendicular to vertical is horizontal.
When it comes to the straight line thingy, if you and me would hold a rope, for example, and I would piss off in a certain direction and start walking, and let's say I walk 5 kilometers, and we have a rope that's 5 kilometers long, and I would radio into you and I say, well, we're gonna hold it straight.
Yeah.
And in order to hold it straight, I would say, well, I'm gonna hold it at 1 meters. You're gonna hold it at 1 meter, and
1
then
meter
it's going to
from
be a
what?
straight.
Though, sorry.
From the ground, or from sea level, for example. Let's say we're on the
So
two
you
boats,
have to
and
make
I'm
sure
rowing away
you're
from you.
both on the same level ground. So how would you do that? How would you make sure that you're both on the same level ground?
Yeah, but then there's just the starting point of the elevation. That's the same. That's what you're basing it on, off, so to say.
Yeah. But you determine elevation as a change in vertical, right?
Mm-hmm.
Well, how do you measure what do you measure that vertical against?
Against the ground.
Well, I'd say
You say
you've
I'm
got to
1
use
meter
water
above
level,
sea
haven't
level,
you?
for example.
You've got to use
Yeah.
water level because mountains and like how do you tell the elevation of ground that does that?
Yeah, so you take the water level.
Yeah, you take your water level and that would establish a horizontal all the way across it. And so then you would know, you'd be able to measure from this horizontal to know what the difference is. Right?
Yeah, and I would determine that the water is level, or if I'm standing level, so let's say I'm on water,
Yeah.
and we tell each other, well, hold your line level at a given altitude. You would, for example, take a plumb line and hold it horizontal to that plumb line.
Well, you don't really need a plumb line, do you? I mean, I've got one here. But you'd have that. That's a plumb line, but that's just perpendicular to the horizontal that's established by the level.
Yeah, and the plumb line hangs down in the globe model because of gravity or whatever, downward attraction.
It hangs down in
Mhm.
reality as well.
Yeah.
Vertically. Yeah. We call this
So
vertical, we call this horizontal. We call this one a plumb. We call this one level.
yeah, so horizontal
Yeah.
in the globe would simply be a 90 or like a straight drop towards the ground,
Yeah.
and that would occur on a ball because of a attraction towards the center
Centre. Again,
center of the ball.
centre of which ball? Right, this is vertical. These are our two frames of reference. Vertical, horizontal. Two straight lines. Two. This one, vertical. This one, horizontal. Where's the curve?
It's there, but it's not visible as elevation.
Okay, is it hidden in the horizontal? Because the horizontal, but this horizontal means that this end and this end, one of them is neither higher nor lower than the other. They're on an equal, right? Equal.
Yeah.
Means, but
The same.
yeah, that means perpendicular to this, doesn't it?
Yeah, and on a globe with gravity, that would work.
What, they would always go down?
Yeah, the plumb line would always point towards the ground.
Yeah, and the horizontal would always be a straight line.
Yeah, on that plumb line.
Yeah. So
at any
if
given
we were
point,
to put water on in here, right? If we were to fit water in here, we would go like this because the water would fill up like that to the. Like that. Right? The water would establish a horizontal plane of reference, and this is the curve underneath. I mean, like, it's just imagined curve. It's not there. There's no way that can be there.
No, because then there is a. You say that it's a given fact that water establishes a horizontal level.
Yeah.
And in the globe, it says that water establishes a horizontal level because of gravity, because of the downward force.
Horizontal, though. Right? Horizontal is a straight line. Straight lines don't curve around balls. So, is that not a... Do you think that's like a linguistic problem? Or sort of a mind trick? To allow you to just carry on believing that it is. The curve there somewhere. But, I mean, the water, definitely, it's a horizontal plane of reference.
Yeah, if you would take a, but that's the problem when it comes to visualize these things.
Yeah,
You're
we
always
do it. We
going to
do
run
that in
into.
reality. Look, we've got tools. We've got tools. Like
Mhm.
it's not hard to visualize it. Those of us that work with this sort of stuff, it's not hard to visualize it at all. I mean, this one,
Yeah, but this is on
this one,
like a
like
distance of
this
several
is a
meters.
tool. You visualize through it. You look through it.
Mhm.
There's a crosshair. It's all visual. It's all practical. What is it that you're imagining when you imagine it? Because I don't have to imagine it. I can do this sort of stuff in reality. What is it that you imagine that makes you think that this is possible?
There's a universe, or there's a downward attraction.
Well, yeah,
So-
vertical.
Yeah,
Yeah.
and I think because in the way you've illustrated it in on the whiteboard, where you have
That's another one there.
a very significant curve over a very small distance.
Yeah.
Mhm.
3. So we've got 3. We've got 3 plumb bobs there, and we've got a horizontal going all the way across. Now, would you say that these plums are vertical, and are the verticals perpendicular to the horizontal that the
Yes,
water
agreed.
line establishes? Would you reckon?
Yeah, I would say that those plumb lines are indeed perpendicular to the horizontal.
Yeah. And the water level is established in the horizontal. And let's say, imagine that we're at one end of a canal, and we've got a plumb bob. We dangle the plumb bob towards the water surface, and when that goes down and hits the water surface, it will hit it perpendicular, right?
Mm-hmm.
There, and then if we have this one here as well, we'll put that down, and that would be perpendicular there, and then this one here, it should be a bit more accurate, but 3 perpendicular verticals onto a horizontal. The water level is the horizontal, and every time, now you could make this across here 27 miles or something like that, couldn't you? And everywhere that you put a plumb bob towards that water surface, it's going to be horizontal. It's going to be perpendicular. One across the other. Straight line. All the way. You could just keep going.
Yeah, and I would say that would conform with the curve of the Earth.
What, the straight lines? Constant perpendiculars of a vertical and a horizontal all the way along a surface of water, a canal, let's say.
Yeah, because if you draw that's the problem with imagining this as you've drawn it. Just as I said, drawing tangents to a circle. If you zoom out a lot, they only touch a little bit.
Okay, yeah, but that's why I said, I asked you at the beginning, how far could you make that water level? How long? You're talking about tiny tangents now. Now, if you're doing that, I've heard a lot of people say this as well. But wouldn't that necessarily mean that the horizontals are intersected?
If you would draw many or several tangents, then those lines would intersect. Yeah.
Okay, and when it was the last time you heard of horizontals intersecting?
If you would say, let's see if I can draw it out.
I can draw you a tangent intersecting with another tangent, right? I mean, everyone can imagine that.
Yeah, I think the disagreement lies fundamentally in the water on the horizontal plane, because we both agree that if I take a glass of water, then that will be horizontal. And I would say it's horizontal because of the downward attraction, which would be equal on
Yeah,
all
perpendicular.
locations of the sphere.
I have to give you that.
Yeah.
Right, so if we start off first with a actual horizontal, right? Because any sphere would in reality, right? So a sphere would obviously, this would be the only actual horizontal in reality you could have, would be on the top or the bottom, sorry, top or bottom of a sphere. Actual horizontal. So you want me to do, we'll do put another tangent on it for you. Right?
Mm-hmm.
Is that good?
Yeah.
So, this one I call the blue one, I call that a horizontal, actual horizontal, but it's also a tangent because it's touching the curve. This one here is just a tangent.
Uh-huh.
Because it's just touching the curve. It's definitely not horizontal, is it?
No, that is not, no.
No. Now, do you know why it's not horizontal?
Because it would not be perpendicular to plumb.
Yeah, and it should be parallel to all the other horizontals, shouldn't it?
Mm-hmm.
So, what you were saying before about horizontals intersecting, it's a bit ridiculous, right?
And because then, well, the difference between this drawing and the Earth would then be that in this drawing, down would be, if you could draw some arrows pointing down, they would all be pointing in the same direction. They would all be pointing plumb.
Yeah.
And on
Yeah, because
the
that's
globe,
how it works.
yeah, and if you draw a globe, or if you would say that's
like, if
the
you
Earth,
want to, do you
plumb
want,
would point
do you want
towards
to
the center.
represent this as a model globe,
Mm-hmm.
or do you want to represent? Do you want to try and represent this as the thing that you live in, like on? Right, or do you want to try and represent it as a model?
Well, I would say represent this as the model.
Okay. Well, in that case, you have to have vertical and horizontal, like everybody knows, don't you? You can't start leaning people off at the side of the model, because you know the model is in here. Look.
And in the model, plumb would be directed towards the center.
Pretend that's a model, right?
Mm-hmm.
And look, you see my little spaceman, Lego man.
Mm-hmm.
Now, I can get him to see?
Yeah.
I can't. He won't.
Because now you have a...
Because it's a model, right? It's a model. There's no way you can make this do what you want to do, because you're trying to mess about with geometry here, aren't you?
No, because...
Yeah, intersecting horizontals doesn't ever happen, ever, anywhere. Ever. Does it?
No, not in what you can directly view, no.
Okay. So... trying to represent it on a model in the place where we all know horizontals don't intersect is a bit, it's difficult, right?
Yeah, because you're talking about viewpoints
Yeah.
that you never see. Now, you would argue that people who've gone to space have witnessed that.
Who would argue that? Would you try and argue that?
I would try and argue that, yeah.
You would?
I would.
Oh, so you would say people who have say they've been to space can argue the fact that horizontals intersect, or the water level is a curve around a circular thing.
Well, they could see that if you have the ball and you would draw tangents on that, which would locally be horizons, then that they would intersect, yeah. Because
But
now in this drawing you
the-
represent down as a
The horizontal, if you
direction.
look in a dictionary, even the mathematical term has it as a parallel to the horizon. All horizontals are parallel to the horizon.
Mhm.
Right, well, how can something that's parallel to the horizon intersect with itself? How
Yeah, because I would
can
say-
a horizontal that's parallel to something intersect with itself? Surely that's got to be fallacy area, right? You've got to at least
that would be
question
an
that.
issue with linguistics.
What,
With how it's defined.
parallel and intersecting?
Now,
I think
on,
I've got the Euclid definition 35, right? Do you know Euclid? Do you use Euclid or not?
I mean, how do I use it?
Yeah. Okay. Well, definition 35, book 1. Parallel straight lines are such as are in the same plane, and which being produced ever so far both ways do not meet.
Yeah, and I would say that there is a discrepancy between the horizons as we see when you look outside, and if you were to zoom out humongously, as in people being in space,
Yeah.
I would say that there is a discrepancy.
Not with
because
parallel,
then you
though.
take because then you would assume that the universal downward attraction, so to say, is like this
It's
universal
vertical.
down.
Yeah, vertical.
And-
That's how we get vertical.
Yeah, and on the globe that would be possible due to a attraction to the center. So any
Well,
point
you
on
can
the
imagine
circle
it. Ah,
would
yeah.
point to the center. Yeah.
But if you do that, you have this problem.
Yeah, then you would have a problem with the definition of horizon.
Who has a problem with the definition of horizon?
Yeah, then this explanation does not confirm that definition of horizon.
Yeah, that's the. Well, it wasn't horizontal. It was horizontals are all parallel to the horizon.
Mhm.
Yeah. Well, I mean, if you take horizon out of it and just use it as the horizontals are all parallel. It doesn't matter what they're parallel to. They're all parallel, so it means they don't intersect. Right? It would be a silly use of the word parallel if they actually meant some sort of intersection.
Yeah, because when you're talking about such scales, then you would talk about tangents.
Yeah, but not horizontals then. Because
No, then you would have
horizontals.
this one horizontal,
Yeah.
and then the rest
this-
will be
this
just
one-
regular tangents.
Yeah. Yeah, but you can't have somebody here with this being the. Because there's tons of fallacies, isn't there?
And there would then be the
chock full of
disagreement on the
fallacies, this
definition of down.
Sorry, a disagreement on the definition of down. Who would be disagreeing on that?
Because then I would say that down is any direction to the center of the ball,
Okay.
and you would say down is down,
Yeah,
basically.
down towards my feet. Yeah.
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 And I would say that locally, you could say it in that sense.
Yeah.
However, compared on the global scale, down would simply mean towards the surface, towards the center.
When you say global scale, what do you mean by that? Because we're talking about verticals and horizontals.
Mm-hmm. When I'm talking about the globe.
Yeah. Well, I'm talking about a scale. Like if we're talking about straight lines, and we're talking about scale, we're just on about making them bigger, right, or smaller, whatever, but keeping the same ratio.
Mm-hmm.
That's what a scale is, right?
Yeah.
So when you talk of global scale, what do you mean by that? You mean at the scale in which a horizontal straight line starts bending around a big spherical object? Is that what you mean by global scale?
On the what I mean by global scale is that you would view every horizon basically as a tangent, where locally, if you then zoom in again, then that would be on an observer on that location would appear to be his horizon.
Yeah, but like every time you would always, I mean, looking at the model, you've already said, if we put a little man here, right, he's gonna if we put him over here, he's gonna start falling off. Right? You can't say that this man's horizon here is that, because the moment you put somebody on here, then the horizontal isn't real. And you're basically saying, well, it depends, doesn't it? I mean, when you're giving us this model at the minute, are you suggesting that everyone lives here? Or like everyone perceives this is the area here that you perceive you live in? Even if you're living over here, right, you can imagine you're living over here, but your actually perception is you're living on this horizontal bit here, where the horizontal and vertical actually work.
Yeah, because the as you would say, to describe it a bit, if you take a circle and you would say, well, everyone would view, or every 1 degree part of a circle, so to say, if you take a circle 360 degrees and take chunks out of it, and you would draw them. Yeah, you take if you take a 360 degree circle.
Yeah, that's it. Like that's a circle. All circles are 360 degrees. Yeah.
And
see if you've got them marked here all the way around.
Yeah, and every segment, for example, 10 degrees, it would all have the same shape.
A curve. Yeah, it's a circle. It's all of its curve. And there's no straight lines on it. That's a problem.
And then,
isn't it?
Now I think that's where the misconception or the disagreement lies.
Yeah, curve or straight. I mean, that's it. Exactly. Is level horizontal? It's a tricky question for people with a model. If you don't have a model like you did when you first came in here, and you weren't ready for this thing, you went with a horizontal, didn't you? All the way across, straight, bang, no problem. Yeah, horizontal. Yeah, water levels, horizontals, all the way across. Mm-hmm. Boom. And then as we've slowly developed into the circle again. I mean, how do you think that happened?
Because then, well, you start by imagining a line on a whiteboard, and then you go to Earth.
You mean the model crept in. Because we started off in reality. You know, we were definitely with the water level, like that was definitely in reality because that's where we were. That's the reality view. That's how I see it.
Yeah, and then I would say that the globe has an explanation for that phenomenon.
This bit, this curve, I would say it's fallacious, right? To presume that this can have horizontals on it, especially a horizontal like you said of a mile. And there's a canal near me. 27 miles it goes from one end to the other. There's no locks. Just all the way from Liverpool to Apley Bridge. 27 miles. And, they say it's all the same elevation.
Yeah, and that would make sense on the globe.
What, you mean it'd be curved?
Yeah.
Or drop? Which one? The hump?
It would curve without a difference in elevation.
Is it a hump, though, in the middle? For each bit of the canal, right? So...
Well, with hump you imply a difference in elevation.
Yeah. Well, you say if there's no difference in elevation... Because
because the difference to the center of the sphere is equal.
This is 27 miles. Right, and then let's go another 27 miles. Right, now, we'll start up here. Right, where are we going to go? We're going to go 27 miles. What's happening? Are we going with the Bislin hump? Or are we going with the nutsack, Kozlowski nutsack drop? Which model between the two?
Now the thing is...
Because if we do what we did before, we've got the one with the hump. I mean, I know it's a bit exaggerated, right? But then for the next bit, we've got... See? So we've got a Sagittar in each bit, in between the locks. I mean, surely that's not going to work, is it?
Well, are you saying that there are two humps?
Yeah, how does...
For each of the 27 miles?
Yeah, well, 27 miles, and then we hit a lock. So it either goes, let's say it goes up there. So the water level goes up, and then we're on to our next stretch of water. And that has to do the Bislin hump, right? Because from each end, it's got to be level, and then you have to have the hump, right? The other way is if you go from here, and then you go down here, right? And then you go up again a bit more because you need the elevation change, right? And then you go down a bit more again. Boom, boom. Right. But then if you want to go back along this canal to this bit here, with this one, you go back down there. And then, I wanted to go back here. So the drop down model doesn't work, but then the staying level in between your two level points with the function of the Sagittar in the middle. I don't know, it's a bit... have you never had this? Have you never thought about this? Because it was Jesse Kozlowski that brought this into the fray, right? Because he was the one that said, this one here, the water level drops down by the rate of 8 inches times the distance in miles squared. Oof, down, down, down. And then this one, when he got Walter Bislin, I mean, he demonstrated this one to Southley.
Yeah, what I would say is that the distance of any given point in that line would have the same distance to the center of the sphere that is Earth.
Yeah.
And because attraction is universal towards this center, a similar elevation is perfectly fine. And
Can
it would
I read
also
a thing,
be...
and I'll leave a little bit out, right? And you fill in the gap, right? And it says, and that a blank may be described from any centre at any distance from that centre. What do you think that blank is? Could it be level?
the distance from the center to
Yeah,
the end.
yeah, may be described
basically.
from any centre at any distance from that centre.
Would not really know.
Well, how would you describe level then? On obviously on the model, like not don't do reality level. Level
say
on the
it's
model.
Perpendicular to plumb.
Okay, well that's horizontal.
Yeah.
Oh, so that you
And-
go with level being horizontal on the globe, but you say it was a distance from the centre.
Yeah, that is on any given point. So
Yeah,
if you take a
yeah.
point,
And
That's its
something
elevation.
may be described from any centre at any distance from that centre. Does that not sound like what you've just said about level?
the level is perpendicular to plumb,
Yeah.
and an elevation of an object is the distance to the center.
Yeah.
And a minus, of course, you only take it from let's say the ground or the sea.
Yeah. May be described from any centre and at any distance from that centre. Yeah. That's how Euclid describes a circle. Seems very similar to your level, doesn't it? Which is very, very different to perpendicular to plumb. Because perpendicular to plumb is a straight line. That straight line, perpendicular to plumb, vertical, is horizontal. Now that's nothing like a circle. That's a straight line.
If you can draw a circle and then every plumb line is a line that goes through the center of that circle.
Nah, that would be called a radius, wouldn't it? That's this.
Yeah.
That's this here. Look.
They would have the radius
all
of a circle.
All of these segments, the ones that divide a thing up, they call these angles because they divide a circle up into 360 degrees. Well, each one of these is like a radial line, right?
Mm-hmm.
And they divide the angle for us to show us how much angles, right? Have you ever heard of them being called verticals? Ever?
Of which point to it again? I was reading.
All of these little segments
Mm-hmm.
dividing a circle up into angles.
Mm-hmm.
Have you ever heard of them being called verticals? Ever?
Only in the context of Earth.
Ah, who said that though? I mean, who have you ever heard saying that a radius is a vertical?
Well, it is described in such a way in quite some physics problems, at least the ones I had in high school.
Oh, right. I've never heard it. You're one of the first people that has ever said it out loud. That a radius was actually not radius, but I mean extension of a radius, obviously, because you think you would imagine you're stood on the outside edge, the circumference, right? So the extension of a radial line past the circumference, you would call vertical.
Yeah, every line towards the circle or towards the center
Do you want me to show you a fun fact that
Go ahead.
you have with this? I'm not keeping you, am I?
No, you're not.
Okay.
I'm drawing in the meantime, or
What
at
are you
least doing my
drawing?
assignments.
Nice.
Yeah, I've got an anatomy class tomorrow.
You see that?
See the box, yeah?
Okay. Now, we'll play the game. We've got verticals sticking out this side, and the vertical going. Well, obviously that one's okay. Goes all the way through.
Mm-hmm.
But we're playing ridiculous games now. So, but we've got a vertical going this way as well, right?
Yeah.
Obviously, because we call this Equator Man, right?
Mm-hmm.
Be honest, do you want me to draw Equator Man on here for you? Not to scale, obviously, not to scale. And another Equator Man, just so you know. See? So, what we've got there, in fact, I'll put Pole Man. And Aussie, wait, look at it. Okay.
Mm-hmm.
So, obviously, they're all stood on the floor with the feet on the floor, and they're all stood on horizontals. They've all got the plumb bobs out, and they've got their perpendiculars and their own perpendiculars, because everybody's special in this place. Everybody has their own horizontal. So, we've got the two pole guys. No tilt. Ridiculous, I know. You'll have to forgive me for it. So, all of these are they're stood on their own horizontals. Yeah?
Uh-huh.
See this? Do you know what that means?
For 90-degree angles?
Yeah. So, although we've all got our own plumb bobs, yeah?
Mm-hmm.
And with our own horizontals, it seems like we have this intersection here. Because, I mean, Euclid says you can extend lines forever. So
Yeah, they're infinite.
yeah. So at this point and this point and this point and this point, what would you call that? It's the intersection of what?
The intersections of the horizontals.
Yeah. Yeah. So because we've all got our own verticals that are perpendicular to the horizontal, have you ever heard of horizontals being perpendicular to horizontals?
No, I haven't.
No, but I mean, your model, the one that you wanted to show, I mean, that's got them there. Did you know about that?
Of horizontals being...
Perpendicular to horizontal, yeah.
Yeah, if you would draw it out, it would look like this. Yeah, sure.
Yeah. So, do you think something that's perpendicular to vertical can also be perpendicular to itself? I mean, that seems like that's a geometric fallacy, right? Like any normal sane person would go, oh, no way, fucking ridiculous. Get off, stop doing that. You can't stand there. We're not having any of this. This is the only guy here. That's the only one that can actually exist in reality. Unless, I mean, you have heard of perpendiculars, and because I've never heard of that. That sounds ridiculous. Never heard of curving levels. Like before I came into this, I was I was just a normal bloke with my son. We bought him a camera. We went going doing stuff, interesting stuff. But then, you know, you meet some people, and some people start telling you really ridiculous things, and you go, "Nah, that can't be true. It doesn't sound right." And they go, "Oh yeah, I'm a YouTube superhero. I'm a Discord superstar. I know science, me. I can say that all of this stuff, this is possible." How's it possible? Dunno. Somebody's just told me. I've got a model. Loads of people believe it. Doesn't really work. I can't see how it works anyway.
I would say that's the difference
What is?
between you and me, because to me that seems possible, and then of course you have a conflict in the definitions, but then you would just call it, I don't know, tangents if you're drawing it on that scale.
Sorry? Just
They
yeah, but
would
you
say-
can't have horizontals intersecting. Or are you just saying you can? You like... Can you think of a possible way that you could do that? Or are you literally just saying it?
Yeah, on this point, I'm just saying it.
Yeah.
So you can take my word, you can dismiss it.
Well, I'm just... like, I know. I've got plenty of proofs that level is horizontal. I don't need any... you know, validation from anybody, or, you know, like your word. But I mean, I like hearing other people's ideas on how they can get it to happen. I've never heard anybody come up with a valid reason on how this thing can happen. Yeah, it's all just imagined nearly all the time. So, if we were to do it again, right, what do you think you might start off differently? Do you reckon you'd still go with the level being horizontal model? Or would you like to take a mulligan on that?
Yeah, I think then if you would say or talk about level on the globe as if you've drawn an entire globe, so to say, or if you've drawn a significant curve, then the how do you say it? Then it would follow that curve, as in the elevation would be equal and therefore straight, I guess. And
Wait, sorry.
Yeah.
You follow the curve, and because the elevation is equal, it would be straight. A straight curve. That's an oxymoron, right? You know, you do realise you just said that, don't you?
yeah,
Yeah.
but if you and me were standing on that globe, so to say, and we couldn't see each other, we would, in order to have a straight line, we would ask each other to hold it on the same or the same elevation, right? Because if your elevation is 1 meter high and my elevation is 1 meter high, then unless there is some weird things going on in the middle, we would have a straight rope, or the rope would be straight.
Yeah, like, you've got to do this over water, though, right?
Mm-hmm.
You've either got to do it over water or spend a lot of time preparing some level ground.
Some level ground.
Yeah.
Yeah.
But when you make that level ground, it's horizontal, right?
And that's I could say, or I would say that because of defining what down is, and therefore what the horizontal line would be, that on a globe that would be possible.
How? Because at a globe, right? forgive me if I'm saying this wrong, right? But it's like spherical, right?
Yeah.
Right. So at any point you are at, in every direction you go, there is a curvature element.
Yes.
Okay. So there is one spot that it will be higher than all the others. If you were
No,
to make
because-
a plane, yes, there's got to be.
Yeah. If you're making a long plane, so
Yeah.
to say, if you draw a tangent out,
Yeah.
then the parts that don't touch the circle, they are going to have a height difference between
Yeah, there's
the surface of the
right?
circle, yeah, and
Yeah.
that horizontal or that straight line.
Right. So you're having to go with the Kozlowski Bislin hump model, right? Because that's where your tangent is. Yeah. Back on the board again. Let me switch this back on. Right. So you've got. See that? Right, you've got two lines there. Now if you drop, I think I was a bit off there, but that and that, they're both perpendicular, those two lines. Now this would be where one bit would be, that would be level point. I mean, it looks familiar, right? We just did it before. Two level points. Two level points, and this is where you say we have to, the guys are stood here, right, holding their hands up. I'm holding a rope, and then another guy here, yeah. Well, this is still perpendicular. This height here was with the height you were measured this at, so you're measuring that height above there and this height above here, and this height is the same above there and there, so that line and that line's parallel, and that one, well, that would make that one parallel too. You just end up with three parallel lines.
But then if you have a ball, that fragment of circle
Yeah.
that you have,
Yeah.
because now you've drawn it, up, so to say, in this perspective.
Yeah.
It could also happen down, left, right on this
Okay.
whiteboard.
So what you're saying is that you want, but these, you're going to need this reference horizontal being horizontal. You can't put this guy down here, can you? How's he gonna do? How does that work?
Yeah, because then
Because he'd
I
have
would
to,
say that-
he'd have to hold his hands right up here, wouldn't he? Elastic out or whatever to hold his bit across there. You'd still need your horizontal reference frame. You couldn't sort of go, well, he's doing it with this guy here. We'll have this one here as a horizontal for him. His horizontal's different than this guy's horizontal because he's moved round this corner a little bit more.
Yeah, and then it's not about moving the corner a little bit more, because then on the globe, so to say, that would be quite a significant distance. And then the guy on the left would say, well, this line is not level because I need to hold it up, let's say, I don't know, 50, 60 meters higher than the guy on the other end has to. Then he says, well, how can that be a straight line? Because
Yeah.
the altitude I'm holding it at is significantly different than yours.
Well, let's say, right, this guy here has a water level. We'll put it in, we'll do it purple. So this guy here has a water level, and he's holding that. And this guy here's also got a water level, and he's holding that. Right? You'd agree with that they're holding water levels, right? Now, let's say this guy's going to have a water level, and he's also holding another water level here for this guy. Now, would that work for you? That the horizontal frame of reference, that the water level that this guy's holding would be down a bit more at this end than because he's round there a bit more.
Well, then the problem is that you're seeing down now, not from the center of the circle.
No, it's a water level. I mean, this guy's holding a water level. This guy's holding a water level. They're making it level. But this guy's got a water level too. He would have to do this, wouldn't he? He would have to have a tube all the way up there, and it would fill up like that. In order to make it level, because that's the only way it works. It doesn't do that. Otherwise, this guy, all the water would run out.
No, because that's not a difference in elevation. Because
what is the difference in elevation then?
No, the distance to the center.
Yeah. Well, that's not vertical. It's a change in vertical. You once again, you're assuming that all of these are vertical. They're not. They're just called radius. What you'd have to do is you have to turn it to put it in this position, right? If you want to make one of these vertical, you have to turn it until it's actually vertical.
Yeah, but on the globe.
No, no. This
on every segment of that circle, the plumb would point towards the middle.
It doesn't do. The plumb book doesn't do that. It points vertically. Only. It doesn't do. It doesn't do this.
Because you are assuming a flat
Doesn't
plane.
do this.
I'm assuming a globe.
You're assuming. I'm not. I'm showing you what happens in reality.
Yes, but on this argument, I'm assuming a globe with a universal downward attraction towards the center, and you're assuming a flat plane with a universal down.
No, I'm just assuming reality. This is the only place I live. It's the only place I deal with. I've never had to deal with any of this other type of geometry or anything that you people are proposing.
And then there's the difference between you and me.
Yeah. I live in reality, and you want to make up stuff just to fit a model. That's the difference, I think.
Well, I think like this has been going on for nearly 2 hours now, I think.
Has it?
And it's
an hour
quarter before 10.
Yeah.
Here. And
okay.
I think
I don't want to keep you.
Yeah, the difference between you and me is just too fundamental when it comes to this argument.
It's too fundamental, I guess so.
Yeah.
You can see where I'm coming. I mean, I know where you're coming from.
Yeah, I see where you're coming from, and I think you see where I'm coming from, if I understand you correctly.
Yeah. Do you understand that I'm coming from the position of reality, and I understand that you're coming from the position of your model?
Yeah, you're coming from this thing that you see and the definitions. And,
Yeah,
go ahead.
I've done a bit of surveying. Have you
Uh-huh.
ever done any?
Me? No.
No.
I study medicine.
Oh, okay.
That's
So
all
I'm
different
coming
field.
from a point of practical knowledge and experience as well. I've got a little bit extra on you.
Yeah, on this thing, yeah.
Yeah. Well, thanks for coming. I mean, what, right, any
You're
time.
welcome. Well, if you've got any questions or concerns maybe regarding biology or medicine, which would be more my forte.
Oh, it'd be keep you in mind. Yeah. It's been a pleasure. I like. Come by any time. It's been good.
Yeah, thank you very much. If you don't mind, well, it's not like I've got to think a lot now because I'm, doing anatomy assignments. So it's more looking things up. But I was also like wondering what's the general jest in this voice chat.
Yeah. Well, we
Because
You've just
deal
been
with
through it.
logical problems and logical arguments, really. Yeah.
I've
Yeah,
got
because,
a
well-
question for you.
Yeah, go ahead.
When Bev was saying about all horizontals having intersections, that horizontals have to intersect with horizontals. You know, when he put the protractor there inside a box, and he said all horizontals have to intersect with horizontals at 90 degrees.
Uh-huh.
There then becomes no differential between horizontals or verticals, because they're all intersecting with each other all over the place.
Yeah, if you zoom out to such an extent.
No, that's happening at every place on your ball.
Mhm.
Everywhere is intersecting with everywhere else. It's just craziness. It's a crazy mess of lines.
If you draw enough lines, everything will become a crazy mess of lines.
Well, unless you have one vertical and horizontal can only be different in elevation. It's easy.
If you use that, the definition for practical applications here.
I'm just talking about what we experience
Yeah.
day to day. We don't experience what you're trying to describe and explain. I've never experienced that. I've never experienced horizontals intersecting with horizontals and perpendiculars to horizontals being the horizontals. It's rubbish. It's complete gibberish. And Bev has just walked you through this, and all you've done is make excuses for things that you can't explain and don't make sense.
Explaining the model as I understand it.
Yeah, but like you say, it's a model. It has no practical examples. You can't give me a practical example of everything you've just said happens. You just can't do it.
Because for this topic, we were discussing the vertical and horizontal lines.
Yeah,
and how
they,
that would work on the globe if it were a globe.
where they intersect all over the place, which doesn't happen in reality. I just can't explain how ridiculous that is to me.
Why is it so quiet?
Yeah, I thought I dropped out there for a second.
I was just working on some graphic.
Oh, yeah, just don't make a break.
my summary kind of killed the conversation there.
Yeah. Is he gone? No.
No,
I'm
he's
still
still
here.
here.
I'm
It's just
still
so
here.
relaxing listening to a ball, believe it or not, lash out every 5 seconds. So
Yeah. That's been a really nice discussion between you and Bev there. But
yeah, that was relaxing.
I still can't odds what you're trying to describe and how you're trying to make sense of things that just don't make sense. It just seems ridiculous.
Hello, DP.
The sun, how you doing?
Yeah, I'm doing good. I just joined and heard your point there. It was a really great point, actually, that it would intersect all over the place, all the straight lines.
Mm-hmm.
It's true. Yeah.
You know, you wouldn't be able to tell the difference between horizontals being perpendicular to verticals. You know, it just becomes a jumbled mess of straight lines.
Yeah. Oh, anyways, I just wanted to check in quick if you were on to something.
No, Bev's just
Well, yeah.
taken. Who was it? Drizzle.
Drizzle. Yeah.
Yeah, me.
Yeah, that
Taken
was
Drizzle through the.
that was
through the
pretty.
whiteboard.
Yeah, you, Drizzle. Yes.
What
Okay.
do you reckon? Was that good? Did it work?
He's talking to you, Drizzle.
Oh, so
are
it's
you going to
me.
be
Oh,
thinking about stuff, Drizzle, more now?
sorry.
You're going to be thinking about more things now when you go out and look at the horizon.
I drop
Or
out.
whatever.
Bye.
Hi.
Yes, son.
That was quick.
Yeah.
In and out.
Yeah, maybe.
Oh yeah, he never posted that video back again.
He did. I think he put it in the
did
other
he?
chat. I think it went in debate discussion.
Oh, right.
He might have posted it in the wrong chat and just deleted
didn't
it
even
from that
think
one.
to
I
check.
think he was talking to somebody in debate discussion. Yeah. What did you reckon, DP? Did I get everything then, or did I miss a bit?
Yeah, I reckon you had it all pretty much in a nutshell, Bev. You know, the points have been. The more we go through it, the more concise the points are getting.
I like the last thing you said, Drizzle, was assuming. You told us exactly what you're doing and what everyone is doing. You're assuming.
Yeah.
Mm-hmm.
Yeah, I noticed that. Like at the beginning, it was solid. Horizontal water level is horizontal. We're in reality. That was it. Slowly, the model started creeping in. It's the on the model, and assuming this and
Yeah.
I've still not had I think the geometry is still a surprise factor.
Yeah, well, you know, when you break it down, you can't argue with it.
Yeah. There's 2 points. Intersecting horizontals that people end up saying. I mean, did you ever think you'd do that, Drizzle? Did you ever think you'd come in somewhere today and say that horizontals intersect with each other? And there is a chance or a possibility that horizontals can be perpendicular to horizontals.
I didn't wake up with that thought. No.
Other than...
Hang on, Bev. Hang on. Right. And Drizzle, if somebody had said that to you yesterday, what would your reaction have been? You would have looked at them sideways, wouldn't you? You'd have been like...
I would ask him to draw it out.
With no explanation, if they'd have said to you that horizontal lines can intersect, you'd have given them a funny look and thought, what on earth is this geezer talking about? Wouldn't you?
I would ask him to draw it out what he means,
Somebody said,
because I wouldn't be up to date with the definition of the horizontal.
yeah,
as Bev
horizontal and
talked.
vertical are perpendicular, aren't they? You go, yes, definitely, yeah, no problem with that. And then somebody says to you, yeah, well, actually, did you know that horizontal and horizontal also intersect? They're perpendicular also. You'd have to say, that's a bit ridiculous, right? You know, like, once you think about the saying, like, once you take it out of the geometry and put it into the logical statement and say that if line AB is perpendicular to line CD, then line AB cannot be perpendicular to line AB. As a logical statement, I mean, that sort of it ends it as a fallacy, a logical fallacy, right? And if you find a fallacy within logic, you've just got to let it go. So I'd suggest that, like, with your model, what you have to do, you have to release logic. You have to have that, like a cognitive dissonance, right? You have to hold it.
Dissonance is something different.
What? What is cognitive dissonance then to you?
I say that is if you're challenged on something that you hold deeply, that incites some kind of usually aggressive emotional response.
Well, I think we have maybe have a bit of a different understanding of cognitive dissonance. Cognitive dissonance to me is it's a part of your brain, and like within your brain you hold two contradictory ideas, but you hold both of them to be true. And the cognitive dissonance happens, right, because at the point that somebody points it out to you, right, and it's how your brain reacts to hearing that conflict. That's why a lot of people lash out and they go crazy. But I mean, other people, it can be a building thing, because you realise there's a conflict, and then you work to fix it. You know, you throw out fallacies, you bring in new ideas to hold, and you get rid of the one that's conflicting. That's what I consider reasonable people would do. They take it on and sort of deal with it in the brain. Other people, a different type of person, does actually lash out and they go crazy. They go into a rage.
And I think the water level is a perfect example of that cognitive dissonance, because you gave the example, you gave the rock solid, yes, it's level, it's a horizontal plane to begin with, and then as soon as you bent it around a ball, you're making all kinds of excuses as to why.
Because for me, then the definition or the workings of down.
Yeah, you say that magical word, gravity.
Yeah.
That makes it true to you. That's your cognitive dissonance kicking in right there, just to make something true.
So you've taken something that your gut reaction was to say, yes, that water is a horizontal plane. That was your first instinct gut reaction. Before you knew where the conversation was going, that's what you were saying, not only to yourself, but to us. And then as soon as you wrapped it around a ball and you realised that that doesn't work in the situation you need it to work in, it was, well, how can I rectify this? How can I make it fit my ball model?
Because even if before this discussion you would ask me what is down on Earth, I would have given you the same answer.
Yeah, but we weren't.
Because of the discussion with lines.
you didn't have the water level in your head if that question had been asked to you?
No, I would not have the water level in my head, no. But I would still give the same explanation. Not because of I'm trying to, fidget some ad hoc explanation.
Well, hang on, the water level's not an ad hoc, is it? It's
No,
a
I was saying that
practical example.
No, I would say that I am not given some ad hoc explanation for this discussion that we were just having. I
Well,
was saying
how
that
do you
I
mean?
would not come up with the ad hoc. I would say that
Hang
the
on.
explanation I've given you now is the same as for another question.
Yeah, because you're fitting everything to your model. But we've given you a practical example of something that cannot fit to your model.
Now, I hold gravity to be true.
Yeah, but you can't have a horizontal indefinite, a horizontal plane that goes indefinitely, that water is on that plane. You can't have it on your ball.
And according to that definition of horizontal, it wouldn't now.
Horizontal is straight line, indefinite, it's a plane.
Yeah, and then the horizontals not being able to intersect.
Well, horizontals don't intersect, do they?
No, and
But they have to on your model.
Yeah, but then we're taking different, because then we're going back to what is down.
I'm going back to what I see, what I observe, what I can prove to myself. And you're going back to where?
To gravity and the direction
Exactly.
of down.
There you go. Something you can't prove, something that's based around a model that has got no evidence for it, that is just make
That's a whole
believe.
different discussion. I'm
Yeah,
saying that as the model stands,
yeah.
I'm saying that as the way the model stands now, that the behavior of the water level would not be in contradiction with the model.
But the horizontal plane that the water level forms, the indefinite horizontal plane, the infinite, as you put it, horizontal line that water level forms, is in direct contradiction to your model.
Yeah, on this definition. Then you would just, you could in a way ad hoc circumvent that by just saying, well, let's not name it a horizon, let's name it a tangent.
No, it's not a tangent though, is it? A straight line on a horizontal plane is not a tangent. Otherwise it would be called a tangent.
Yeah, but then you're not seeing Earth as a globe. Then you're seeing a circle
But
and
you're
drawing a
assuming the
horizontal.
globe to put a tangent underneath it, or to put it
now
underneath a tangent.
We are
now we're having two
seeing
different
horizontal
discussions with each
water
other.
levels, though, as a tool. Like, we are definitely seeing that. Like, that is an established fact that a level, the tool, establishes a horizontal plane of reference. You can't get around that. Doesn't matter what you're seeing, or you think you're seeing, or you think you should be seeing.
Or what you name different lines, whether it's a tangent or a horizontal, the water level forms a level. A
Tricky one,
horizontal
mate, isn't it?
plane of reference.
Yeah, it's always bending. It has to always bend on a ball. It can't just decide to be straight for a mile and bend to fit your model.
There are no straight lines on a sphere.
None.
How would you try and find the curve? How would you measure it?
That's advanced, that. Spot on. You can't just come in and
drop that one in his lap. That's a bit of a bombshell, that one. Spot on.
Well, just food for thought, that's all. Oh, it's Drizzle, is it? Sorry, I didn't recognise the voice.
New guy.
What's up?
Hi, Drizzle. Nice to meet you.
Nice to meet you too.
Yeah,
Is
you've
he a
missed.
nice one, people?
Oh, yeah, he's
is he a
lovely.
nice one?
Yeah. Like perhaps, maybe tie-in for the nicest baller I've ever met. Possibly.
Oh,
What?
Helgi.
Yeah, he's
Helgi's
like
pretty nice.
he's a Helgi. You know, he's not. I don't think actually. No, he can't quite be as nice as Helgi. Have you ever met Helgi, Drizzle?